let's go ahead and look at what one of those carbon atoms looks like. So, you know, we saw in the previous video that the Hope diamond has 4.6 times 10 to the 23 carbon atoms inside of it. Well, each one of those atoms has a mass of point blah 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 zeros 2 grams. Okay, this is basically a zero number, and instead of reporting it as zero, we do know that these atoms do have mass, so we need to be able to report it in a way that is much easier to write, much less time consuming to express than what we have written here. So in this problem, I had to multiply, whatever my coefficient was, times 10 23 times, and that's going to give me a big number. Every time I multiply something by 10, it gets bigger and bigger and bigger. Okay, well, what I need to do is figure out how to express a small number, something way smaller than 1. Okay, well, I know if I divide something by 10 a bunch of times, I can end up getting fractions or decimals, and so this would be dividing by 10. However, with scientific notation, we're stuck with multiplying by 10. This is a standard format here. The times 10, that has to be there. Okay, but another way that you can write multiplying by something a certain number of times as dividing is to say multiply by 10 to the negative exponent. And okay, this just means you're dividing by 10. Okay, so if I look here, we still have to follow the same rules. We want to have a number between 1 and 10 in our coefficient. All right, I've just got a bunch of zeros here, and you read these left to right just like you normally would, so I wouldn't say 0, 2. Okay, that 2 is there. I don't want my decimal place in front of the 2 because that's going to give me 0.2, and that is less than 1. I still remember your number for your coefficient needs to be between 1 and 10. Okay, so I'll say coefficient needs to be between 1 and 10, and we can go ahead and say it can also be equal to 1, but let's not make it equal to 10. Okay, so in order to do that, I need my decimal place to be over here on the right side of the 2, because then now my coefficient is 2, which falls in the accepted range. Okay, let's see, how many times do I need to, in this case, divide by 10 or multiply by 10 to the negative however many times? So I'm going to start originally where I was. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, almost there, 23 times. So to make 2, that's a big number compared to this one. It's greater than 1. To express 2 as a number smaller than 1 and to actually express it as this exact number here, I need to multiply it by 10 to the negative 23rd power, and that means that really I'm just dividing by 10 23 times. Okay. Again, this is a naked number. You don't walk around saying 2 times 10 to the negative 23, that's what a carbon atom is. What? Okay, what about the carbon atom? No, it's that's how many grams it weighs. That's its mass. So each carbon atom has a mass of 2 times 10 to the negative 23 grams, and this is the exact same number as this up here. Way more efficient to write and talk about.